Hello friends, this is Akshita, your educator. I welcome you on the platform of Sparda Pariksha by Global Online. As we know friends, Global Online platform has launched a complete series for upcoming CTET examination which will be held in December 2022. And in this particular series, we were dealing with Mathematics Paper 1. In today's lecture number 10, we will discuss about the mensuration part number 2. Friends, if you want the guarantee selection in the upcoming CTET examination, also want to score maximum marks in the examination, this platform is going to be one-stop solution for you because we will provide you with different courses for paper 1 and paper 2. Let us discuss one by one the features that have been provided in this complete course for paper 1 and paper 2. For the teachers, Central Teacher Eligibility Test 2022, the complete course for paper 1, in that we will deal with the full syllabus theory lectures, practice multiple MCQs, mock test, full syllabus notes, and the course fees is again of just 2000 rupees. You have to go and download the Global Online app and contact us on this given particular WhatsApp number. Moving to the paper 2 course, similarly, the full syllabus theory lectures will be provided, practice multiple MCQs, mock test, full syllabus notes, course fees is again just of 2000 rupees. You have to go and download the Global Online app and contact us on this given WhatsApp number for enrolling the course. Friends, the students who want to go for paper 1 and paper 2, for them again the same features will be provided to you in the fees of just 3000 rupees. So if you want to score the maximum marks in the examination as well as want to do the exam oriented preparation, then this course will act as a one-stop solution. Here you will be provided with the compiled preparation. Okay, now last step that you have to follow for enrolling the course, I'll explain you within a minute. Over here you have to go on Play Store, download the Global Online app. Here you will find such interface. Okay, here you will move downward, you will get a icon called store. You have to click on the icon and move to the page number 3 where you find the courses wala page. Okay, here you will find the search tab where you have to search for the particular course. Here you will provided with the filter courses like live courses, test series, recorded courses, and different again courses by the Global Online. As Global Online is a platform where you can go for the preparation of different entrance examination like CET, NET, PhD entrances tests are also carried out over here. Basically, when we go and search for the exam, you will find the different courses along with the fees. Okay, fees will also be displayed over here. So this is the course. This will be very much beneficial for your upcoming CTET examination. Okay, now in today's lecture we'll be discussing about the mensuration part number 2. In yesterday's lecture what we have discussed is about the 2D and 3D structures. Okay, in the mensuration we have discussed about the 2D and 3D structures. In 2D we saw the triangle, circle, and quadrilateral. In quadrilateral we saw the structures like square, rectangle, rhombus, parallelogram, and trapezium. Okay, moving on to the 3D structures, we'll be discussing today cube, cuboid, and cylinder. Basically, I told you if you're going for paper number 1, triangle and circle are the topics from where questions are never asked, have never been asked in the CTET examination, in the previous examinations of the CTET. So basically you have to focus on the quadrilateral wala part, in which you have to focus specifically on the square and rectangle. Okay, now in 3D structure we'll be discussing in detail more about the cube and cuboids. Okay, so this course actually will be dealing with the mensuration part 2, in which we'll be discussing about the 3D structures. So let us move into the notes of yesterday's. Okay, so this was all we had discussed, the questions about the square and rectangle. Now in today's part number 2, before moving into the part number 2, let us discuss what we have discussed yesterday, what we have deal with the topics yesterday in detail. Okay, now the very first quadrilateral that we have seen is over here. This was square, right? In square what we have seen is, we saw that all the sides are equal. Very first thing we saw that all the sides are equal, and we also saw that the angle formed by two different sides is forming 90 degree, right? This one side A, this another side A, both forming the 90 degree. When they touch each other, they are forming the 90 degree angle. Now the perimeter, when we discussed about the perimeter, these were the boundaries that we were discussing, right? The perimeter was 4A for the square. Area was equivalent to A square. Okay, now A square can also be written as d square divided by 2. It means that d is the diagonal, and as we know diagonal by the Pythagoras theorem, when we find out the value of the diagonal, it will be a under root 2. So basically when we find the value of a from the diagonal wala formula, we'll get that a square is equals to d square divided by 2. Okay, this is something, please do take the screenshot of this. It will be gonna be very beneficial for you. This is the important topic regarding this square. Now moving to the rectangle. Okay, what we saw in the rectangle was the opposite sides are equal. Okay, in this we saw the perimeter is equivalent to twice of L into B. Perimeter, again the boundaries. If we take here, we can find that if we go for plus, if we do summation of all the boundaries, what we find is there are two breadth, there are two lengths, right, which are equal in which sides are equal. So if we go for 2L plus 2B, instead of that, what we will take is perimeter is equals to 2 in common L plus B. This is what we saw regarding the perimeter. Moving to the area, we saw the area is equals to L into B. Now here, for finding the value of diagonal, what we find is diagonal is equals to under root of L square plus B square. This is something I have introduced in today's slide. The diagonal value, diagonal is equals to under root of L square plus B square. Please note down this point again. Now the questions that can be asked basically from the rectangle, we'll discuss these points in detail later on. But moving on to the topics of mensuration, 3D structures, we'll be discussing about the cuboid. Okay, before moving to the cuboid, let me discuss what is the prism. Now basically, what is prism? Prism is something, for that, consider a base. Okay, let us consider a base. Whenever a base is simply remaining the same till upwards. Okay, now how? Consider this one diagram. Look at this diagram. In this diagram, what we are finding is the prism. Sorry, I'm not able to draw this properly. Wait, look into those diagrams now. Okay, so what we can find is, if you're considering one base, okay, this base is continuing till complete shape has been formed. No changes in the shape has been taken place over here. Okay, same shape is maintained till upwards, or till the shape is completing, till this complete structure is forming. Such base forming structures are called as prisms, where the complete structure of one particular part is remaining the same. If we consider it like drawing it once again, if I take this one particular shape, this shape is completely maintaining till it comes upwards, right? This shape is still maintaining, right? It is still maintained. So such shapes where the shapes or the structures have been maintained are called as the prism. Okay, these are called as the prism. Now in case of prism, whenever we see such prisms, what volume we have to take is base area into height. Now there are different prisms, we'll discuss each one by one. In prism, what we found here is volume is equals to base area into height. This formula is common for all the prisms. And if we go for the surface area, we'll take the base perimeter into height. What we are doing over here is, look at the volume wala formula, right? Volume is equals to base area into height. As I told you, in case of prism, the base structure is remaining the same. For example, this is the base area, right? This base area is remaining the same until the complete structure has been formed. No change in the shape has taken place, right? So what we have to do while finding the volume is take the base area, find the base area. Basically we'll take the base area of this particular square, okay, or particular any kind of shape that has been given the prism, okay, and what we will do is, for finding the volume, we will multiply it by the height means how much upwards the shape has been formed or the structure has been formed. Okay, so basically for finding out the volume, what we will do is base area into the height. For finding the surface area, again what we will be dealing with is we'll finding the base perimeter. Now we'll find the base perimeter. This perimeter, once we will find it out, and then we'll move to the height. कितने हाइट तक ये आगे बढ़ा है और how much height it has moved upwards or downwards, whatever the shape it has taken place, will take that as the height, that is surface area will become base perimeter into height, right? As we know, this is the base, right? This base is moving forward, right? So this is taking the height, for example, h, right? This is forming the height called h. So here what we can find is, first thing what we'll do, we'll find this base perimeter, a single base perimeter, and then we'll deal with the height. Such bases will come in all that height. So this is what, how we find the surface area for a particular prism. This is the in common formula, okay? Whether you go for the volume wala formula or the surface area wala formula, here this is the way how we find the prism's volume and surface area. Now we'll discuss the examples of the prism in detail. Before that, I'll tell you again a part where we'll discuss what is the opposite of that of the prism. Now in prism, what we have seen is that the base is remaining the constant until a particular height where the structure is forming, right? But in case of pyramid, what is happening is this particular base, for example, is not continuing till upwards. It is not continuing till upwards. What is happening is this shape is getting into the tapering ends. Okay, here what is happening is there is a formation of slantation, or we can say the points together are joining with each other, two different points here. Okay, so what is happening is it is forming a particular it is forming a particular slant height, or we can say it's taking a formation tapering ends. Tapering ends means what is happening over here, that two different points are joining together. For example, if this was a prism, this cone, if it was a prism, what would have happened? This would have taken this particular shape till upwards, right? This shape would have maintained till upwards particular height h tak, the same shape would have maintained, right? But what is happening in case of pyramids? In case of pyramids, what is happening, that the structure is not maintaining and it is having such kind of end, that is the ends are getting joined. Okay, so such structures are called as pyramids. So in that we'll be discussing about the cone. Okay, so this is something that is not important for the paper number 1, so we are just discussing this not much in detail. Okay, now whenever we find the volume of a particular pyramid, okay, the volume, any pyramid given, what we will do is volume is equals to 1/3 into base area into height. What is the difference in the formula of the prism and the formula of the pyramid? When we look at the difference, check the difference. Now in case of prism, what we are taking is volume is equals to simply base area into height. Whenever we are saying the pyramid over there, we are taking the volume is equals to 1/3. Basically we are cutting it into the 1/3. Okay, we are taking 1/3 of the base area into height of a particular prism, or you can say the volume of prism का 1/3 पोर्शन हम ले रहे हैं यहाँ पे. ठीक है, वॉल्यूम इज इक्वल्स टू 1/3 ऑफ बेस एरिया इनटू हाइट. वॉल्यूम इज इक्वल्स टू 1/3 ऑफ द बेस एरिया इनटू हाइट. हियर देयर इज नो नीड फॉर you to go and rectify all these stuffs. You just have to keep in mind, whenever we are taking any prism, it means the base or any structure is maintaining its shape till upwards, okay, until the structure is been formed. But in case of pyramid, the structure is not maintained, it's having such kind of tapering ends or joining ends. So here the volume is equals to, in case of prism, base area into height, where the volume in case of pyramids is equals to 1/3 of the base area into height. Whenever we are dealing with the surface area in case of the prism is base perimeter into height. Here similarly what we will do is, instead of taking height, we will take, so instead of height we have taken simply slanted. This is the only difference between the surface area of a prism and surface area of pyramid. So here you don't need to rectify, simply you have to go through the formula once. Now let us move to the examples of the prism. Now very first example that we have to deal in detail about the cube. Okay, cube is an example of the prism. Now look at the structure of the cube. What we find here is there is one base. That base, this base is continuing till upwards. right? This is maintaining, that is here we can find in case of the cube that it is maintaining the structure till upward, so it's called a prism. So what we find again, the thing over here is we can see that in cube all the sides are equal, all the sides of the cube are equal. Okay, now basically moving to the volume wala formula for the cube. As we know, cube is a prism. We have seen in case of prism what we will take, volume is the base area into simply the height. So base area into height is the formula, common formula for all the prisms, and here for the cube what we will see is that the base area, first checking out the base, we see that the base here is a square. Okay, look at the base, what we find, the base over here, it is a square, right? It is a square, it is a square in shape, right? It is a square in shape. So for square what we take, the area is, area of the square is equals to a square, right? So in case of volume of cube what we will take, the base area is a square. Okay, a square, and height is what again, for height we will take a, right? For height we are taking the side, one side, that is a, so basically it will become a cube. So when we deal with the formula for the cube, what is the volume, then for a particular prism, common prism formula for the volume formula for the prism is volume is equals to base area into height. What we find, the base area in case of the cube, the base area is a square, so base area will be will be taking as a square and height as a, so the volume of cube is equals to a square into a is equals to a cube. So here such, if we go through such kind of explanation for the formulas, no, so you don't need to rectify the stuffs, right? So nextly, total surface area. Now what is the total surface area? Look at the cube, how much surface do you find? If we go and do and check, we find that there are complete 6 surfaces. How come? Look at the figure again, the above portion wala one square, the last wala one, this one, right? The lateral 2, right? Upwards and downwards. So total how much surfaces do we find here? There are almost 6 surfaces, right? In case of cube we find 6 surfaces, 2 faces at lateral sides, right? 2 faces, that is area surfaces at upward and downward side, and 1 front and 1 at the backward side. So there are total 6 surfaces that we find in case of the cube, right? So here again what we find, the total surface area, how we got the one fact that here there are total 6 faces, there are 6 faces in case of cube, then we'll be dealing with the total surface area as 6a square. As we know, the surface area, it means that we are taking for the each square, right? So there are total 6 squares over here, then we'll take what will the formula for the total surface area of the cube, then it will be the 6a square. Once again I will tell you, what we have taken is the volume of cube. When we are dealing with the volume of cube, we'll take the base area into height. And what is the base area over here? The base area is considered to be a square over here, so we are taking the surface area of the area of the square, that is a square into a, that will become a cube. And total surface area is equals to what is the total surface area? For that we need to see how much faces of the cube are there. We find that there are total 6 surface of the faces of the cube. When we go through it once, we'll find that upwards and downwards is the two face, front and backward are the 2 faces, and the lateral 2 faces are the faces of the cube. So total 6 faces of the cube are found over here. So basically when we go for the total surface area, we'll take it as 6a square. Now what is the diagonal? What is the diagonal over here? Diagonal, it means, consider you are sitting in one room. Consider that in which room we are sitting, if we have put a big stick or a big rod from one upward point of that room to one downward point of that room, if we are taking a big rod, so basically placing it in such a way that it is occupying the maximum place, right? It is actually occupying the maximum place of that particular room. It means that from 2 different points how much bigger rod in length we can place in that particular room. That is nothing but the diagonal. So such kind of questions can be asked to you in the examinations regarding the rod, regarding the stick, okay, or uh, for example, a question can be asked like, place a particular rod or particular stick in a particular room so that it is occupying the two points of the room, okay, the two upper and one above, matlab upper wala point and one floor wala point, okay. So in such a way we have to place the rod so it is occupying the maximum length over there, okay. Such kind of questions can be asked. So that is nothing but the diagonal. It means we are connecting the two different points, we are connecting the two different points, one from the upward and from the downwards point, right? So this is the nothing but in diagonal in case of the cube. So here the diagonal ka value d is equals to under root of 3a. So this is something that is really important. This question can be asked in the paper 2 specifically, the questions on the diagonal. Moving to the next prism structure, that is cuboid. In case of cuboid, again all the side, what is the difference, basic difference between the cube and cuboid? As we know, in case of the cube all the sides are equal, but in case of cuboid the sides are not equal, they are different. So basically length, breadth and height here over here are different. So here when we find the volume, as we know, whenever we are finding the volume in case of prism, it is the base area into the height. Here we have to take the length, breadth and height as the volume because all the sides are different, right? So moving on to the total surface area. In case of the total surface area, what we find is, to find the total surface area of a cuboid, consider each face as one rectangle, right? Whenever we find the surface area or the area for the rectangle, what we will take is a into b, that is length into breadth, right? That is length into breadth. So for each rectangle over here, consider each rectangle in case of cuboid, consider this one, right? If we are considering this one, what we find is the area for this particular rectangle is equals to what? Length into breadth. It means length into h over here, right? It means L into h, that is LH. When we consider this kind of rectangle over here, this one rectangle over here, what we find here is the area, particular area for this rectangle is equals to what? This is equals to length into height again, sorry, length into breadth again, so that this will be b into h. So when we go for this upward wala rectangle or the downward wala rectangle, one and the same it is, right? When we see this, what we find the area over here, what we find the area is equals to L into b, right? So again, in case of cuboid, each face is having its opposite side, right, and which is similar. So here there are complete how much faces? Here we find total 6 faces. So here what we will take is 2 into LH plus BH plus LB, because each face is equivalent to the opposite wala face over here, right? So here the total surface area will be 2 into LB plus BH plus LH. This is how we derive the formula for the total surface area of a particular cuboid, okay? Now the diagonal again, the particular 2 points that we have connected, there the diagonal is equals to under root of LBH. So these are the formulas that you have to keep in mind regarding the cuboid. Now the very last prism that we'll be dealing with here with is cylinder ka volume. Now before understanding the volume and the curved surface area of a particular cylinder or the total surface area of a cylinder, we must be able to understand regarding the perimeter and the area of a circle. Okay, now these are the two formulas that you have to keep in mind, that the area of a circle is equals to pi r square. And sorry for my voice, I'm actually not quite well. And the perimeter is equals to 2 pi r. Okay, now, and what is the r over here? R is what? R is the radius. So whenever we are finding the area of a circle, we'll take the formula as pi r square and perimeter as 2 pi r. Okay, 2 pi r. This is the only formula that you have to keep in mind. So from circle, such questions have never been asked regarding the area of the circle or regarding the perimeter of the circle. So you have to just keep these formulas in the mind for solving the questions of the cylinder, or for solving for solving the volume or the total surface area of a particular cylinder. This is question something that is been asked in the paper 2. So this is important for the in perspective of the paper 2, not in the form of the paper 1. Okay, so here the volume is equals to pi r square h. We'll just discuss with the formulas, but this is because this is something that is regarding the paper 2, not the paper 1. So here the volume is equals to pi r square h, and the curved surface area is equals to 2 pi r into h. Okay, what we are taking what we are thinking now, what is the curved surface area? What is the curved surface area? Actually, this is the surface area that is the surrounding this particular area, right? This one, this is the curved surface area, right? This is the curved surface area in which this above two faces are not included, right? In the curved surface area, we are discussing only about this surface area. This surface area, we are not dealing with this one and this one. We are not dealing with these two surface areas, right? So here we are just simply dealing with the curved wala area jahan pe above two faces are not included. Okay, and in case of total surface area, we are discussing about the total area including these two faces also, right? So basic difference between the curved surface area and total surface area is, in the curved surface area, all the area is included in the cylinder, in excluding this above and below face, right? Above and the below face. But in case of total surface area, we are dealing with all this curved surface also and this above and the below face also. Okay, so this is the basic difference between the curved surface and the total surface area. Now the formula given over here is 2 pi r into h. The formula given here is 2 pi r into h. So as we know that we are discussing about the perimeter here, 2 pi r. So whenever we discuss about the curved surface area in case of cylinder, here we are dealing with the surface area including the height, total surface, because consider here all these are all the circles, right? These are all, wait, I'll draw on another diagram. Here look at the curved surface. Here we are finding different circles, right? Here we are finding the different circles. So when we deal with the curved surface area, consider one circle over here and find the surface area, that is the area of the circle, that is 2 pi r. Okay, such different circles at particular height h will be the curved surface area of the particular cylinder, that is 2 pi r for one particular circle of circle, right? When we take into the height, that will be the total curved surface area of that cylinder. In this way we are finding the curved surface area of a particular cylinder, right? Moving to the total surface area again. Now total surface area, as I told you, in this two faces are also included. So what we will take is, we'll take this curved surface area plus 2 pi r square, right? We are taking 2 pi r square, that is the area of the circle. We are taking the area of the circle over there. So here what will be the formula? 2 pi r square h plus 2 pi r square. 2 pi r square is the area over here, and what was the 2 pi r? 2 pi r was the perimeter. So here what will be the formula? If we go, it will be 2 pi r taken in common, h plus r. So in this way, this is how we find the total surface area, where you don't have to rectify the formulas. Just go through this lecture once, and once you understand how the formula has been derived, then you will be able to understand, and do not rectify the formulas. Okay, do not rectify the formulas. This will simply be kept in the mind if we know how the formulas have been derived over here. Okay, this was all about the cylinder, that is the prism. Prism में हमने 3 structures देखे अभी तक. That is, one, we have deal with the cube. Okay, nextly we have deal with the cuboid, and nextly moving to the cylinder. This was all about the 3D structures that can be asked in the examination. Pyramids have never been asked in the paper number 2. Okay, so in part 2 today's lecture, we have seen the new formula for the diagonal of the square, diagonal of the rectangle. Now the questions that can be asked in the case of the rectangle, these questions can be asked. This will deal with it for once. Okay, then you will be able to understand the rectangle also in detail. Now the questions from the rectangle have been asked before in the examination, like if we are considering one rectangle with length length L and breadth B, okay, and outside the rectangle we are taking a particular road, or we are considering a particular road of p meter. Look at this rectangle. This is the rectangle, right? This one is the rectangle, and outside of the rectangle, we are considering this path of p meter. We are considering this path of p meter, okay. We are considering this path of the p meter, and we have to find exactly the road that which has been kept from outside, right? So if we have to find the area of that particular road that which is outside that of the rectangle, then how we'll find it? Area is equals to 2p. Now p is what? P is the road that we have kept of particular meter, ठीक है, x meter, consider it. Area is equals to 2 into p, L plus b plus 2p. Okay, this is the formula when we consider a particular road which is outside the rectangle. Okay, but when we are considering a particular road which is inside that of the rectangle, then what will be the formula? Here, this is the rectangle, this one is the rectangle, this one is the rectangle now of length L and breadth B, and here this particular inside path, this is the particular inside p wala road, okay, p meter wala road we are considering inside the rectangle. Here we have considered this road outside of the rectangle, here we are considering this road inside that of the rectangle. Then how we'll find the area of the road over here which is inside the rectangle? Area is equals to 2p L plus b minus 2p. So basic difference between this both the formulas is that when we are considering the road outside of the rectangle, we'll take plus 2p, and when we are considering the road inside that of the rectangle, we'll consider it as minus 2p. So this was all about the formulas we were discussing. Here we don't have to just rectify the steps, just go through the formulas once and do screenshot it. This is very much important. Take this screenshot of this one. Rectangle, this one is again important. In rectangle we have seen these cases in which the road was from inside and the road was from the outside. The basic difference between the formula was when the road is from outside, then we'll take plus 2p, and road from inside minus 2p. In mensuration 3D structure we were discussing about the prism. Prism में basic formula for volume and surface area we have deal with. In prism we have discussed the various examples like cube, cuboid and the cylinder, and just keep in mind the formulas for the area of the circle and the perimeter of circle. This will help you in the volume and the total surface area and curved surface area of a cylinder. So this was all about the today's lecture. I'll give you one question. Please do solve it and drop it the answer in the comment section. Okay, try to solve the question. Okay, the very first question, find the height of a cylinder. Find the height of a cylinder whose radius is 7 centimeter and total surface area. Once again I am telling you, total surface area and curved surface area. There is a basic difference. In total surface area we are considering both the faces from above and below also, right? So the total surface area is 968 centimeter square. You have to find the solution over here. We have to find the height. I'll give you the options. Option is 14 centimeter, option number B is 15 centimeter, option number C is 16 centimeter, and option number D is 18 centimeter. Okay, this is one question. Please do screenshot it and comment in the comment section. This will be the question number 1. And another one question, if cube has its side length equal to 5 centimeter, then its area will be. This is a very basic question. Okay, you have to find the area. I'll give you option over here. Option number A, 160 square centimeter. Option number B, 132 square centimeter. Option number C, 150 square centimeter. Option number D, 172 square centimeter. This is one question. Please do screenshot and answer in the comment section. Another one question. Okay, again one question I'll give you. The height, length and width of cuboidal box are 20 centimeter, 15 centimeter and 10 centimeter respectively. Okay, find the area. You have to find the area of a cuboid over here. I'll give you the option. Option number A is 1300 centimeter square. Option number B is 1232 centimeter square. Option number C is 1432 centimeter square, and option number D is 1700 centimeter square. So these are the three questions that you have to answer in the comment section, and tomorrow I'll deal with its explanation. These are the very simple questions. These have been directly this can be directly derived from the formula. So these questions and answers will be discussed in the next lecture. At the same time, we will start with a very new and fresh topic in tomorrow's lecture. So please do answer these questions, and we'll also discuss about what are the exact right answers in the next lecture. Okay, thanks for watching today's lecture. This was the end of today's lecture, and thank you for watching it. And if you like my video, please do like the button, hit the like button, sorry again, and please do subscribe the channel. And if you want to enroll the course, do just contact on that given WhatsApp number. You can simply do enroll the course at the same time from the global online application also. So this course will be providing you a compiled preparation where we don't have to follow different kind of sources again, or notebooks, textbooks and different kinds of papers and all. This will be the one-stop solution for you. So please do join the course also, and please do like the video, and if there are any kind of suggestion, you can drop in the comment section. Thank you for watching my video. Stay tuned for more such videos. Bye.